you have watched the video, this is also explained, but for the sake of completeness, let me do this. Let me share my paper. It's my paper. Okay, I think this is the one. Uh-oh. Let me double check. Yeah. Okay. Okay, so this is where we stop, right? This is where we stop. Let's continue with this one. Let's continue with this one. And I think the question here in the slide is that, okay, what we want to do is to find the velocity of this parachutist, right? And we know that when we do the free body diagram, okay, this is what we get, summation of forces. Okay, in this case, upward is positive, Outward is positive. So, upward minus downward, and it will ask you for the velocity. So we have CV here. C is what we call the the coefficient of the coefficient of drag. Okay, this is velocity, and m is the mass of the parachutist, and g is the gravity. So the question is, how can we find the velocity here of that parachutist? Because we know when somebody jumps from an airplane, okay, what happened is that we'll have okay, we have this. Okay, so when you jump, okay, this is before you jump, the velocity is 0. Once you step out of the airplane, your velocity will go very fast, and then it will slow down and basically become a constant. So this is what we call the terminal velocity. Terminal velocity. Okay, so this is time, this is your velocity. So what we want to do is to find what is this velocity. Okay, what is this velocity? So how do we do this? How do we do this? Okay, how do we do this? Okay, so what we have here is that this one. If you look at the next slide, this is the governing equation. Remember, the first step is to understand the problem, and using the appropriate physical law to model the problem, and then we come out with the what we call the governing equation. So this is the governing equation. So the first is model the physical problem using physical law. Okay, so in this case, what we have here is this. Okay, is this. This is the physical problem. And what we did was we draw the free body diagram. Okay, we draw the free body diagram, and we use the appropriate model, physical law. Second, from part 1, get the governing equation. Okay, so now the next step, and in the slides, it's already given you the governing equation. So let's see how we can get the governing equation from the physical problem using the physical law. So remember that this is a dynamic problem, right? So we say that summation of forces must equal to ma. And the summation of forces is that summation of force is equal Fu CV. This is Fu upward, going upward. This is going downward. Okay, so that's the summation of force. In this case, what I'm going to do is so okay, so what I'll do here is that note that my G is going downward as positive, right? So what I'll do here is summation of forces going downward as positive. Then what I have here is mg, which is the downward, minus cv must equal to ma, right? So what I'll do next is note that what we want to do is to find solve for v, right? So what we want to find is we want to solve for v. All right, so look at this. Note that this is mg minus cv equal to m. A is just basically dv dt, right? dv dt. Note that now we say we want to solve for v. Can we use algebra to solve this governing equation? So this is our governing equation. Can we solve that using algebra? Remember I talked about type of math that we can use. We can use algebra, we can use calculus, and so on, right? So in this case, can we solve this using algebra? Anyone? Anyone? Am I here? Am I online? Anyone? Okay, can we solve this using algebra? We know what is M, we know what is G, we know what is C, and the problem is we do not know what is V, so we need to solve for V. Okay, remember this is what we want, solve for V. Anyone? Anyone? Please say something. Am I still online? Tak ada orang ke ni? Tak ada orang ke? Okay. Okay. Zainuddin. Apa dia? You raise a hand. You raise your hand. So, okay. Before that, let's simplify this. Let's say I'm dividing everything by m. So this is g minus c over m v equal to dv dt. Note that this is the same equation as this one here. Okay, this is the same equation as this one. Okay, except my arrangement is not the same as the one in the slide. So what I'll do is, because we are trying to solve the unknowns, okay, unknown is v. So what I'll do is I put v on the left-hand side. So I have dv dt minus c over mv equal to g. Okay, or maybe I'll keep the let's delete this. Let's do this dv dt equal to g minus cm over v and solve for v. Okay, so how do we solve this? Okay, use your math. I believe you learned this before. Note that our V appears in two formats. One is V on its own, and the other one is V in derivative form. So when the unknown is in a derivative form, this is what we call a differential equation. So this is what we call a differential equation. Okay? So this is what we call a differential equation. So what we need to do is to solve this. So this is what we call a differential equation. Because V is full derivative, dv dt is a full derivative. So this is what we call ordinary differential equation, or what we call simply ODE. And you learn this during your first year math, first year math. So ODE. So how do you solve for ODE? So this is ODE. So use ODE techniques to solve this. But remember, this is an easy ODE, so we can solve it analytically. We can solve this analytically, or if it's too hard, then we need to use we need to use numerical methods. So note that this is first derivative, and when we have first derivative, okay, because of first derivative, so we need one condition. Okay, one condition. So the condition in this case is that at time 0, what is the velocity? What is the velocity?
0.
Because remember, this is t0, right? So what is your velocity? Because you haven't jumped from the airplane yet. So this is the boundary. Sorry, this is the initial condition. This is what we call the initial condition. So now we can solve this problem. We can solve this problem because this is first derivative. We need to have one condition that can be used to solve our ODE. Remember last time, we have two unknowns, right? So we need two equations. In this case, we have first derivative. So we need one condition in order to solve for the ODE, for the ordinary differential equation. Right, so when you do this technique, this is what you get. This is what you get. This is the solution. So this is the solution where we have V equal to GM over C, 1 minus all these things. So note that we have V as our dependent variable. Why? Because it depends on T here, which is our independent variable. So V depends on T, where T is the independent variable. There are other terms here. So we have forcing function. G is a force. G is a force that pull you downward. So this is a force. G is a force. M is the mass. C is the coefficient of drag. So this is what we call the parameter, M and C. So forcing function, a parameter that has force basically. So in this case, G equal to 9.81 meter per second squared. So this is a force. So this is what we call a forcing function. M is a parameter. C is also a parameter. And T is a parameter, but this is specifically what we call the independent variable. Independent variable. So our plot here is Vt equal to Gm over C, 1 minus E minus P over M P. Right? So that is the solution for our paratritis. So I don't want to go how we get from here to here. You will learn this in your math class. So I don't want to go into that. So now the next one, this is some of the common equations or balances that we use in engineering. So remember last time I told you Engineering, we have normally conservation of energy, mass, and momentum. Conservation of mass, conservation of momentum, and conservation of energy. Okay, these are the three main rules in engineering. Maybe there are others too, but so far, I think in mechanical, we use a lot of conservation of mass, conservation of momentum, and conservation of energy. Okay, so we are done with this topic. Okay, and I believe I have posted the slides, the error analysis, So I do not want to go into that, but what I'm going to let me go to the e-learning portal. Okay, can everyone log into e-learning? I want to show you something. So give me 1 minute. Okay, so let's share. Let's share my screen now. Uh-oh. Something is not right here. Let's share. Where is my... Okay. Okay, so this is the portal. So I posted the recording last time, how to study for this class and how to get good grade for this class. Okay, so this is the one. And this is basically still, okay, basically today is 27, but this is for 20 to 26. And I posted the mathematical modeling lecture slides and error analysis. I also posted the lecture videos. And today we have a quiz. Okay, we have a quiz. Start from 9 to 9:10. Basically, you need to download the question paper. Okay, from 9 to 9:10, and then submit the answer here. Submit the answer here. Okay. This is about this one, error analysis. I hope you have watched the video. I hope you have downloaded the slides. And today we have this quiz one. And the quiz ends at 9:50. So you need to download the question paper first from 9 to 9:10, which is in 10 minutes. And then submit it either here or here. Okay? Any question about this today's assignment, about today's quiz? Any question?
No, doctor.
Okay. No, if there's no question, what we'll do here, let's take a break, 10-minute break, and then come back to this page and download it. At this moment, if I click this link, it will say this quiz is not currently available, right? So it's not available yet. It will be available at 9 a.m. sharp. Okay, so you have 45 minutes plus 5 minutes submission, a total of 50 minutes, which means 9 to 9:50 until the end of class. Okay, until the end of class to submit. So once you're done, then you can submit it here. You can submit it here. Then of course you need to upload. I think my view cannot do that because I'm not a student here. I'm not a student. Okay, so if there's no question, what I'll do here is before we take a break, what I want you to know is that there'll be assignment after this. I'll post an assignment later today, and it will be due on next week, on next Sunday. Okay, next Sunday will be due. All right, so this is part of your 1 hour post, sorry, not 1 hour, 3 hour post lecture, 3 hour post lecture. So doing the assignment, please take, please take no more than 3 hours. Okay? If you take more than 3 hours, then something is not right lah. Something is not right. Maybe you do not understand a lot of things. All right, so let's take a break. And then, I think I think let's end the lecture today, but you still have to do your assignment. You still have to do your quiz. Okay? So, any question before we go? Any question before we go?
No,
No,
Doctor.
Doctor.
Okay, good.
Okay.
So, I'll see you again next class, which is on Thursday, right? On Thursday. So, don't forget, please do the quiz. Please do the quiz. Thank you very much, everyone.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.